Your SAST tool found 120 problems. Your team spent 20 hours sorting through them. You fixed 15 real vulnerabilities. What happened to the other 105? They were false positives. Noise. Every single one. That means 87% of your security alerts are wasting your team's time. Let's put real numbers on this problem. We tested traditional SAST tools across open-source repositories and found an 87% false positive rate. That means for every genuine vulnerability you find, there are 7 false alarms sitting next to it. At $100 an hour for senior engineers, triaging takes about 10 minutes per alert. That works out to roughly $2,000 per project just investigating noise. Tools like SonarQube, Sneak, Checkmarks, and Aikido all contribute to this problem. Here's where it gets really interesting. We ran a case study on NocoDB comparing traditional SAST against semantic analysis. Traditional tools generated 222 total findings. The number of true vulnerabilities in those 222 findings? 0. Every single one was a false positive. Meanwhile, semantic analysis found just 5 findings, and all 5 were real vulnerabilities, including a critical SQL injection in the Oracle client that traditional tools missed entirely. So how do you actually fix this? There are 5 approaches that cut through the noise. First, context-aware filtering. This distinguishes between vulnerable code and production endpoints versus dead code, test files, or sanitized functions. Second, data flow tracking. Instead of examining lines independently, you follow input sanitization across application boundaries. Third, logical grouping. This consolidates related findings by root cause. 50 alerts become one actionable issue. Fourth, entry point analysis. This verifies whether flagged code is actually reachable from user-facing interfaces. And fifth, semantic understanding. This means comprehending the code's logic rather than relying on pattern matching. These approaches work. Across 45 repositories, semantic analysis detected 225 real vulnerabilities with a 90% maintainer acceptance rate. That acceptance rate is the number that matters most. It means maintainers looked at the findings and agreed, yes, these are real problems that need fixing. At the same time, this approach eliminated over 1,000 false positives compared to traditional tools. The difference between noise and signal is the difference between security theater and actual security. Traditional tools generate reports. Semantic analysis generates evidence. Your team deserves tools that respect their time. Your codebase deserves analysis that understands context. Visit collega.dev to see how semantic analysis finds real vulnerabilities that traditional tools miss. Stop drowning in noise. Start finding what matters.